the end?
So last year the goal team won the game. There wasn't a lot of scoring in the first half, but the teams kind of figured out the best strategy. So you saw a lot of back and forth in the second half. And the goal team was up by, I think, 3 points with 5 seconds left. And the blue team had the ball and was charging down the field to try to score. And they got their running back into the open field, but he was tackled in the sense that one of the Gold Squad robots ran into him. And it wasn't a hard enough hit to register the tackle sensor we have on the robots, but it was a hard enough hit to pop the ball out. And so that fumble, as soon as the ball hit the ground, ended the play according to last year's rules. And so it wasn't a tackle that would have stopped the progress, but the fumble with no time on the clock as the ball carrier was headed toward the end zone actually meant that the goal team won the game, and there was sort of the explosion of the students cheering. And it was really serious because it was set up such that influenced their grade. So the gold team members got more points for their final grade than any of the blue team members. We changed that this year because it seemed unfair that a single play, right, that could have swung the game either direction influenced the actual grade in the class.
Hey, that's football.
It is, but it's not engineering class. And so we instituted the idea of an NFL Combine-like event this year, where you have to qualify all of your players. If you have a running back, it has to do a speed test, a controllability test, it has to do a handoff test, and then there's a maintenance test where you have to swap out the battery in a specific period of time to prove that you have a disassemblable and a reassemblable robot. And it's very much like an NFL Combine. The students actually chose most of the events that occur in the Combine because they looked at last year's game and said, this is what we need our players to do in the game to be successful. So these are the metrics by which you should evaluate players, and that has created this Combine type event that's a week and a half before the game. So they have to have their players built in advance, and the Combine takes place in the same step-in center where the game will be played. And the students qualify all 11 of their robots, and their grade is largely based on how well their individual players perform in this NFL-type Combine.
So how much science really is behind it?
So they're working on what we call trade studies right now. They could do this project just by intuition and feel, and it, quite frankly, it probably wouldn't be successful. What we want them to learn in this class is there's some of that intuition and feel involved, but then you've got to go and run some numbers. And it's not like a homework problem they're used to in their other classes where you put a box around the answer, it's right or it's wrong. There's an infinite number of ways to design these robots and to make them work, and little things can trip you up. So there's very little science in the prototypes that they're doing, right? They build them out of wood, they put wood screws in or glue them together to try to make them work, and then try to get some feel from that as to when they actually make it out of engineering materials in the formal version, is that likely to perform the way we expect it to? So they're doing calculations on all of these things. For the passer, they're trying to figure out what velocity they need the ball to have to travel what we call a short pass. We actually give scoring points for completed passes. And a completed pass means you actually just hit the receiver. It doesn't have to retain the ball. It can, and they're trying to design those capabilities, but it's still a reception if you hit your receiver. And you get more points if you throw it 15 feet as opposed to 5 feet, or even a screen pass is a modest number of points.
So Coach Kelly would say that there's a lot of life lessons taught by football. In this particular version of football, is that accurate too?
It's exactly what we're going for in the class. I mean, typically when engineering students do a design project, they work with maybe 3 or 4 other people, and that's a life lesson in itself. And they've got to work in that group and make it function. We've created a scenario now where they have to work with 33 other people. And you may be on the quarterback group with 5 people building the quarterback, but if the 5 people building the running back that you're going to hand off to don't communicate well with you and get the job done, then you're sunk, right? You can't perform in the Combine the handoff test. And so we've tried to emphasize to the students that this is very realistic with what they would see in an engineering industry environment, like they would say at Motorola, where you don't just work with 3 people. The success of your project, putting on a game of this scope requires the efforts of 35 people on each team. And if you can't work in that environment, you can't then extend that to a project on the scope of what you see in industry, where you're working with a very large number of people, and you can't do everything yourself. So we think it's a great life lesson, and in the same way that football is. We're putting it's an 8-on-8 football game here, and if one of those robots doesn't function, in the same way that if somebody misses a block on the football field, everybody suffers. And so it's a team scenario from an engineering perspective.
So what's your long-term vision for this competition and what it's teaching students and where it may take them and your research as well?
So I think I would love to see other schools pick this up as a class in the way that we have, and limit it to 13 weeks design time, essentially building from scratch every time. But another avenue to go is to make it a club activity that would go year round, like some other student competitions. And it would be great fun to have schools that don't have a football program, like the MITs of the world. Even some of the Ivy Leagues that do have football programs that aren't so competitive, and have them go up against big engineering schools like Purdue and Ohio State and Notre Dame that have historically strong football programs as well as historically strong engineering programs. That's I think an exciting opportunity, and the students get excited about working on this project, which is what we want. So I think those are two ways to go with the competition. I would love to see, and I think I'm seeing it in some of this year's students, is some of these students to take what they're learning from this football experience and apply it in robotics research in things like intelligent prosthetics for our wounded, or even doing a better job of prosthetics for the other 90% who can't afford actuated prosthetics. You think about the number of amputees in the third world. You're not going to put a powered prosthesis on a kid from South Africa who has no money. But there is technology that can be applied to make an inexpensive prosthesis that's a better functioning device for those children. I'd love to see some of these students work in robot-assisted rehab. That's a research area that I work in with some folks in computer science and psychology here at Notre Dame. What can we do with technology and robotics to enhance stroke rehab, spinal cord injury rehab? How can we use that technology to speed rehabilitation and to give people a more complete recovery of their previous abilities?
So Notre Dame football does more than make you yell and cheer. It can actually help in the long run to spur some real science that could help people's lives.
That's absolutely right. We have graduate students who are supporting this activity, whose research funding comes from this activity, and they're working on concepts for shoulder mechanisms that would improve the mobility of amputees that have very high amputations on their arms. It gets kids excited about the technologies that they need for these types of research. It brings attention from the world to the research we're doing in these activities, and you never know where that's going to lead. Someone captures a sense of what you're doing and gives you the next idea that pushes the research forward.